Welcome to a Saturday. I have a number of things I'm going to do today. Mostly figuring out some cabling. I did get some stuff in from AliExpress. Nothing major. What I was after, and I bought these things. Let me just get the board in question. Just a sec. I can't see it over my shoulder here. Here it is. So what I wanted to do, first of all, and this is why I ordered from Ali. See these I2C ports? Here, let me zoom in some more. Yeah, okay. So these guys right here, I wanted them to be like a toggle switch. So I went out and I got two things. I got some of these. These are 1.27 pitch surface mount jumper blocks. Right? And I got some, I have one out here, a switch. My problem is, though, when I place this on here, let me just unplug the I2C, like so, it doesn't match up with the pads. You can see it's way too big. So I thought, okay, well, maybe these guys, because they're closer together. The problem is it's where's my pokey device? The problem is we're looking at two different sizings here. We're looking from the center over here to here, like so, and we're looking from this to this. So as you can see, these pads are very close together, designed to be solder joined. And then this way, like so. So this guy here is obviously also the wrong one, right? In theory, this is just a 3. It needs to be a bit bigger, so neither one works. So I thought 127 would work. 254 would be too big. That is on par with one of these things, right? So this is 1.54 pitch. And you can see here it's also off. So this is between 2.54 and 1.27, probably like 2 millimeter pitch, I suspect, right? So I couldn't put them in, so these guys didn't work. So I've gone to plan B. I found on the net these little PCBs. And do I have a picture of it? I think I do. Let me find my AliExpress page here. And we'll just go to my orders. Oh, it was a sheet, if I remember correctly. Here, this guy here. So see, these are little circuit boards. They're designed for, as you can see, SOP 8. And SOP 8 has 1.27 pitch and 0.65 pitch. So if you flip these boards over, they have a different sizing on them. So that's one side. That's the other side of the board. So there's 0.65 millimeter pitch. There's 1.27 millimeter pitch. Now the idea of these little boards is to convert that chip into dip. Well, I'm thinking I could put on the back of this thing, this guy here, one of those little boards with wires going to the pads. Now, this row here where the numbers are, they're all common. So I only need one wire to go across, one wire to connect basically to here, and they're all connected. And then I need 4 wires coming off here to the other side of that little PCB. And then on that little PCB, I can put that and solder that on. And the result is we have little dip switches. So that is my goal, but of course those parts aren't here yet. I bought a couple of sheets of those things, so they come in like 10 pieces. So I got 20 pieces of them. They're cheap, like you can see on the here, 52 cents a sheet. So wow, I might be going overboard there. But that's the idea, and that's where I'm kind of stuck at the moment with those. Now, of course, some of these things, these things like the sensor boards, which do have yeah, so let me get a sensor board without pins on it. So this is a sensor board, for example, and it has the same idea. But as you see, it's I got lots of real estate in here, but not as much real estate on here. I'm really dying to see how exactly big those little circuit boards are. I think I could put one on here too, on the bottom, and then I just select the thing. Now I have come up with a third idea how to deal with this, but it would require making a custom PCB. So these pads are really big, like you can see. So I was thinking of a little board that would go over top of this, and in the board would be the holes to deal with these pins, and then just like the PCB, the legs on it for soldering the switch part. And what you do is you place the board on here, and then through the plated through holes you just drop solder so they stick to all these pads. And then you have like a daughter board stuck onto this board, soldered on, and on that daughter board you would have the dip switches, like an adapter plate basically. I don't know yet. I have to see how things go. So that is kind of my idea behind that, right? And this was, I have these because I want to do my trophy thing. And the other thing I have to learn, I guess, is how to do, I think it's 3D Fusion or something like that. How to make templates so I can run it through a 3D printer, right? So one of the guys at work has a 3D printer. Another guy I know has access to a bunch. So yes, I'm not quite ready. I simply don't have room around here for a 3D printer. It would be nice, but sorry. Now it's all for really mail. Now from Amazon, for the 2C Plus computer, its serial ports are 8-pin mini DIN. The 2C, on the other hand, the one I blew up, was 5-pin DIN. So I needed to make a new serial, have a new serial cable. Now luckily, apparently, they make this. Now I don't know if the pinning to this is accurate. So if I go over to the web page here, and let's see if we can find the page I was on. Here. So this is the Apple mini pin 8-pin to DB9 thing. So what I have to figure out here is, okay, so according to the diagram, I'm just going to stretch this out a little bit. According to the diagram, when I look at this 8-pin DIN that way. Oh, why is my face off on this one? Just a sec. Face cam properties. Okay, unlock the face cam, please. Oh, that's why. Lock the face cam. There we go. Well, that didn't work well. Well, apparently we lost the face cam for a moment. Properties. Let's see if we can knock it back into function again. Come on, guys. Did I lose it on the main one too? I wonder. No, all the other cams are working except for that one. Oh well, I'll just turn it off at the moment. Have to look at that later. So what we need to do is on these pinouts here is figure out which is which. So I've got my little stand here, and I'm gonna zoom back now. So we're gonna mount our DB9 into a clip here so we can work with it. And we will mount our DB8 here, making sure we kind of orient it right, so like so. There we go. Then we need a multimeter. And we're going to find out what our pins are here. So on the DB9, and I have to kind of pull my glasses off to look at this. Okay, so 1 is right there. Okay, so that's pin 1. Going to pin 5, then 6, pin 9. Okay, so they're saying here pin 1 on the 9. For example. Boy, you really want to move, don't you? Let's do it that way. There. It has to go to pin 7 on that. So if we're starting here on the row, 7 is the middle one at the top. And we don't have a beep. Let's make sure of that. I'm not getting a 7 from anything here. It's like pin 1 is not even connected. Let's try again. Pin 2 connected. Wow, that's really good connector. Come on, don't get on the microphone. Okay, so why do we have nothing? Let's try pin 5 here. Well, pin 5 here is connected to pin 2. Pin 4 here is connected to nothing. Wow, this is not a good sign. Looks like I'm gonna have to hack the cable. Let's try pin 6 on this. Oh, it's like I'm not even making a connection inside of here. What can we do about that? I have some wire here. Let's try sticking the wire in. No, this is solder. That's solder. That's solder. That's wire. Come on. Let's try a wire down 1 here. Are we actually getting a connection on here? Nope. So this cable is a failure. It might be a DB8 serial, whatever, but it's sure not doing anything properly. So what we're going to do is we're going to hack it. So, time for the tools. We need a cutter. Probably a knife, maybe, to cut the sheathing. So let us do that. Okay, that's just trash. Okay. So I want to keep a reasonable length. Let's cut it about here. Okay. Let us trim. Okay, so first thing I'm going to ask myself, yeah, I got a ground wire, and I've got 2, 4, 6 wires in here. So the wires we care about, of course, on a DB9 on here. So we need, out of the DB9, we need 3, 4, 5, 6, including the ground wire, 7. And I'm pretty sure pin 1 is ground. So let us do that. And well, this is not good. Okay. I need to strip the ends off these guys. So we need our super duper stripper duper. Where is it? It's in here. Here we go. So let us, I'm just going to take the glasses off for this since it's easier to see. If you don't have one of these guns, it's worth investing in one. They're pretty cheap on AliExpress. Okay, there. Okay, so we stripped them all. Get my glasses back again. Okay, so let's try this now. So Damn it, I've done this like 3 times now on this stupid cord. Come on. Cut it out. And what did I just do with the cord? Oh, it's in my hand. Okay. Okay. So, let's find out where the red wire goes. Red is pin 1. Okay, so we need some notes here. And we need a writing stick. Let's see, in here, 1 writing stick. Yes, primitive band. We're going to write with a writing stick. So we know that on the 8-pin mini DIN, 1 is red. 2, 3, 4, 5, 6, 7. Okay, so we'll just confirm that again just to make sure. Red, and according to that diagram, this way, yeah, red, orange, is 3. Okay, yellow, make sure we're not touching something else. Three, 4, 5, 6. 6 is yellow. Next one, let's do blue. Blue, 6, 7, 8. Blue is 8. So 8 is blue. Brown. Well, this is going to get weird. I don't think I have enough wires to match what's in the cable here. 4 is brown. That leaves green. It's 2. So 5 and 7, at least just this bare wire, and I don't think the bare wire connects to anything except the should be the shell, but it's not. Nope. Now, according to the Apple pin mini DIN, 5 has to connect to 3. So 5 is unconnected in the scale. This whole 8-pin mini DIN is only 5 wires, and it's incorrect. So it's a good thing I went for backup plan. Ta-da! An 8-pin mini DIN, both ends. Okay. So we're gonna have to make a cable, so we'll cut here. And we'll just throw our spare piece somewhere. There we go. And cut with our knife here. So, how many wires do we have in this one? 1, 2, 3, 4, 5, 6, 7, 8, and a ground. Oh, that's looking a lot more promising here. So let me see, is our ground shell correct? Okay. Now let us strip all these wires. And I will just take my glasses off again. So we got all these wires to strip. Oh, they're going to be a bit of a bitch to strip. Okay. They cut, but they don't actually strip. They don't get a grip on them. I have another tool for doing this, just in case this wire seems to be a little finer. Oh, come on. Okay. This guy here. Come on. There we go. So we're talking really fine stuff. There we go. I wonder what gauge this is. 24, 22. Let's put it on the 22 and see what happens. No, looks like 24. Because I tore the sheathing. So let's do 24. Yep, 24. We don't have to strip the ground. So 24. There's black. And there is orange. There is red. 24. And one more left. Brown. Okay, so let's find out if the color pattern matches the thing here. So we said that red was 1, so let's find out if red is 1 on this one too. That would be a good thing. Nope. On this cable, red is 3. Okay. What about brown? Brown. Brown is 2. Okay. Next will be orange. One, two, three, 4. 4 is orange. You know, you kind of wish there was a standard on this. So we need wire number 5. Let's try Mr. Black here. Whoops. Are we making actual contact? Well, black is 1. Okay. Let us try the next wire, which is yellow. One, two, three, 4, 5. Yellow is 5. Okay. Green is 1, 2, 3, 4, 5, 6. Green is 6. Okay. Purple. Has to be 7 or 8. 8. And last wire, Mr. Blue. Which one are you? 7? Yep. Blue. Okay, so we now have a cable that actually has all the wires in it correctly. Okie dokie. That is the 8-pin mini DIN. That's that one. Now we need to deal with this cable. Sure, we'll clip this off so we don't need all the excess cable. Okay. So I know on this cable the gun works, so we'll do the gun. Oops. There we go. And there's your yellow. Mr. Brown. And Mrs. Orange. There we go. Okay. So what we need to know on this one, so I'm going to start a new note and close the knife before I cut my fingers off. So this is going to be so I'm just going to transfer some notes here. 8-pin mini DIN. So 1, 2, 3, 4, 5, 6, 7, 8. Black is 1. Just put no notches here. Black, brown. No, shut up. Brown, red, orange, yellow, green, blue, and purple. Okay. Now I wonder on this side, is the shell actually attached to that? Okay, so we don't need this. At the moment, we do need this. So let's find out if the shell is attached to ground. Wow, what a bad DB9. Wonder if it's attached to 1. Nope. Well, let's try pin 2 and see if which one of these is pin 2. Nothing. And we need the 2. That is really crappy. That's no good. We can't have that. We need another DB9 piece here. Do I have another one? So what do we have here? 5-pin DIN, and we have some more cable in here. That's a 9-pin female. Sorry, male. Is my cable in here? Do I need the other side of the world? Yeah, I do. Okay, so I need another side of the world here. So we got half of it working, and I don't think I have another DB9. I don't even think I have a pinnable DB9, like when you make pins on its own. I don't think I do anyway. Remember there was one kit in here somewhere, but I don't know if that was the right one. "37 pin D sub." No, I don't think that's it. It's not what we want. One moment, please. I am going to pause, and I'm going to go look in another bin across the room. Pause it. Is it recording still? Well, apparently I don't have one. I have a ton of them at work, but not here. I have DB9 to male, but I do not have DB9 to female. So the reason the problem, and I don't even have a gender bender. So this on that serial cable needs to be female, and I don't have that. So this, I have half my serial cable, but I don't have my other half. So that'll have to be worked on later. So what else did we were working on? Oh, I did get some, put that on there before that wire can go there. The pokey thing can go over here. The side cutter thing can go in there, and the pokey thing can go in there, and the knife can go in there. We don't need it at the moment. And this can go over here. So, in this bag. Yes, I have to constantly keep up with crap around here. I did some restructuring on my computer bench. I took a shelf out and I moved the whole main monitor back, so it gave me a little more room. Do I have the brightness on a little? There we go. Sorry, lost the train of thought there. So I can't work on the serial adapter. I can't work on the floppy adapter. The boards came in from PCBWay. Here they are. Ta-da! The idea is they go on top. See, I have a feather that's kind of upside down with the legs in it. I haven't soldered anything yet because I want to solder the section first to the center one, and then I'll do the outer ones. So the idea is that would plug into something like this directly, or we use something like this where we have the board over here and we have these. I have a bunch of these in 2s, 3s, and 4s. So if you're curious, the most expensive part about this is actually getting delivered. Okay? Not the actual boards. The 10 boards cost me $6. And you get to pick the color and whatever you want. I picked black boards. I like them. But I could have picked one of a dozen colors. So I can't do anything with that at the moment. That is on hold until the rest of the AliExpress stuff comes in. And if we go look at, so now I've got some others. So this guy here, is for a thing I've been working on for a couple of months now, ever since I got this proto board. So here, I'll get it out. So this here, I've been slowly populating where the board's things go. So this is the MP3 player, this is the ESP, and then turn the board around. There's the motor driver, and this guy here under here, I believe they said it was level shifter, and this guy here is the step up module. I put in the blue connectors, I put in all the extra sides, link, everything like that. So all those are in place. Now the only board I'm missing in here is either the what they call the LM2596 DC module or a battery shield. Either one can go in here. So if it's a rectangle like this, it's the DC. If it's a little square in the center, is the battery shield. So I believe this is the input for it. So I have two different one of these things. This is this one, and I also have their original, this one. This is really an Arduino development thing. Now the other thing is, I can't remember if I have an Arduino Mini here, right, to populate the mini spot. So I have the Nano, I have their shieldy thing that goes on here, and underneath I have plugged into here a classical, is it on a tilt? I think it is. Yeah, it is on a tilt. Something's not plugged in correctly. Oh, for some reason this is not in correctly. Let's try again. Yeah, it's kind of hard to get all these pins lined up and plugged in correctly. That's a little better. So the idea is all the pins from these things all come out here and here in various places, and you plug them in and you put your circuitry on here. So yeah, you know, I swear I thought I had a mini. This is my Arduino bin WaveCat Atmega Pro Mini. Oh, will you look at that? Does that fit? Yes, it does. No, it doesn't. Yes, it does. No, it doesn't. I think the problem I had, and I think this is the issue, is these rear holes here don't match up with here. I think if I match up for pins here, I can get all those pins. But the holes on the outside here don't match. And that happens to be the WaveCat version of it. So I'm probably going to have to go find a different, slightly different Pro Mini than these guys here. Spare nanos and da. Yeah, see. Well, what's in here? that a different one? Ah, let's have a look. Knife. I think I might have a slightly different model in this one. Or is this just a... you know, I swear I just cut this. There we go. Oh, I put a ding in my mat the other day. This mat, and I can't get it anymore. Well, I can't get this particular one. I got it because it didn't have any funky lines and shit on it. So, nope, this is the same one. Yeah, same problem. I thought these might be different, but no, they're not. So, we cannot do anything with that. So, whoops. Suppose I should throw this back in here. There we go. So that's the idea behind both of those. So I'll have to hunt for another Arduino Mini with the holes like that, not off by one. Then I could fit the Mini in here, the Nano in here, the Uno in here. And on the back, of course, is all the breakouts for everything. What all the pins mean and stuff like that. So, yep, but that's the idea. That can go over there. So, now the one other thing I was going to look at today is a bit on the programming side. I have these guys here. They are the ESP32 cams with the USB on them, and the ESP32 cams without the USB on them, but I've got the daughter board for it. And by the way, they're tricky as heck to program. You have to get that kind of the pushy button thing just right. But I was looking at a interesting thing in here, and it was called and let me just find it here. Arduino, and it was oh, what was it called again? Something like WiFiManager. Yeah, so the idea behind WiFiManager was a little bit of code you add into your thing, and for a moment what happens is when you first power this thing up, it acts as a access point, I think it is, and you can connect to it, set your security on it, and then when it starts up again, it then acts like a client instead. So you don't actually have to hard code your credentials into here every time. And there was a drone bot thing about this thing that was really good. So if you don't know about drone bot, it's another channel. WiFiManager. So this place here, and what we're after here is this thing here, the WiFiManager. Okay, so I thought I would try to add the code. I've got CircuitPython, sorry, not CircuitPython. I got Platform.io up, and I've got the ESP32 cam software in here. What I need to do is add the WiFiManager library, like so. And of course my face is frozen in every one of these. I wonder if I can reset the one webcam. Where is it? Yeah, that one. It's on this one. Let's try that. And I'm going to go up here and oh, come on, go away. And face cam properties. There we go. Fixed. So this is the SP32 cam software. It can load onto either of these units. It doesn't matter because they're basically both the same idea. So what we're going to do is add the WiFiManager in here. So I need to go Mr. Home here, libraries. And so we want WiFiManager by Zapu here, this guy right here. Okay. Add to project. And we're going to add it to the cam project. Okay, successfully added. So we need to add this line, for example, to ours. So we need, and I think he's adding it to, not the demo, we want to add to an existing one. Yeah, ESP cam. So he's in the cam web server one. This guy right here. So we're going to add in here that. And now I make sure I got the right camera. ESP32S. I'm pretty sure AI thinker is what these guys are anyway. I don't think I have to change anything. So then we're going to add in so we need to find what's called WiFiManager, where we initiate the instance of it. We need the Wi-Fi begin. Right here. Okay, original replacement. So we need to replace the Wi-Fi thing. Yeah, we're going to replace that whole block. So this guy here is going to get rimmed out. And if I go like so, I just rimmed out the whole block there without actually getting rid of it. And then we need the code here. And here. Try that again. There, like so. Although we don't need this crap here. Somehow we got some weird characters in here. Okay, and I'm just going to go like so. Okay. So you have a baud rate. We initialized that. Are they putting it all in? No, they're just putting in the void setup loop, which is in here. Okay. Okay, so he's got a lot of extra code here for something else. I just want to test this out. That's saving parameter data. So what are we complaining on problems here? Include errors simply. Platform ini control. Yeah, it's there. So why does it think it's not there? ESP286 is Wi-Fi.h. You can't open that. ESP8266 Wi-Fi. Oh, okay. Maybe I have to add another one. ESP8266. Let's see what do we got. Okay, WiFiManager. I got that one. Driver LSD. We're not finding it right away. ESP. Did I get the right thing? ESP8266 Wi-Fi. Let's try that. ESP8266 Wi-Fi. Ping manager Google, TTN, MQT. Oh, this is not good. You're linking into a library. Don't know which one you're linking into. It's not good. Okay, let's try this from a different approach here. Okay, this is funky. If you're using the development version of WiFiManager, the standard release version does not have ESP32 support, which is why they're trying to include the Wi-Fi library. You can use the development version by changing the lib. Okay, let's do that. Copy. What they're talking about is this line right here. The lib depth, control V, home, hash, control S. Okay. Control S. Okay. Oh, that's broken too. Okay, so why are they not getting it? Of course, all of you gobbledygook here is I can't find things again. Cannot process command get clone recursive. Wait a minute. I know I reinstalled the OS. Did I forget get? No, get's there. Cannot find remote branch development to clone. No, they don't have one. There is no development. Let's change this to master. And let's try build again. Okay, different error. Stray /302 in program. Oh, okay, I know what that is. This fucking cut and paste from this stupid DroneBot site. He doesn't do his web page correctly. Where is it? Yeah, see here. Let's try the build again. Oh, this is annoying. There's all these hidden stupid UTF characters in here somewhere. Wow. A function is not allowed here before token blah. Well, his code doesn't work, and this code doesn't work, and it should be just an if statement. Are we one squiggly out? That matches. That matches. Build again. Nope. We're still having a frickin' problem with brackets. Function definition not allowed here before the token. Okay. That bracket matches that bracket. Oh, that's what's happening. I am out of whack with a bracket. Let's see. This while closed off with this bracket. And this bracket here is in the wrong place. Cut it out, Windows key. This, Control S. Let's try building again. Res doesn't name a type. Boolean. Duh. Why do you think you don't res a type? Error. Expected unqualified ID before if. Oh man, this is ridiculous. What is with his code? WiFiManager WM boolean res equals blah. Holy crap. That should be the frickin' code. Oh, maybe. Oh, I might have done something wrong here. This whole section, cut it out. Over scrolling. Cut it out, cut it out, cut it out. So this section here, copy. And this section here. Like so, it's supposed to be in there. That's better. Okay, let's build it again. That's much better. Okay, so let's find a cable. And I keep knocking on these glasses, so let's just move them out of the way for a sec. So let's take a camera here. I've got one, and we'll plug it in. And did I get the right one? Yes. D-message on cameras. Yeah, okay, I got one. Okay, so let's see if we can push. Here we go. So you have to push the flash, then the boot, let the boot go, hold the flash a bit, and then let go. Okay. Oops, I didn't mean to do that a second time, but I'm going to do it anyway. So this should show up as a thing. So we need a phone. Just a sec. So we need a phone. Okay. So we need to manipulate the Wi-Fi. So that Wi-Fi internet. So we're supposed to see in here this one. So let's see. So what was the name they gave this? Auto Connect AP. You don't see it in here. Okay. So, well, the code's compiled, but I don't think I have it quite complete yet. I might have to turn the debugging on, because obviously we're not seeing auto connects in here. So, okay. Let's see if I can connect to... Can I connect to a serial? We are... I don't know which one we are. Huh. USB 0. Oh, I wonder if we're communicating at the wrong... Oh, it's 9600 should work. Let's try a reset here. No, wrong baud rate. Control T. Never done this in here actually. Control C. Okay. So yeah, let's put the serial monitor in under setup. So under serial begin. Oh yeah, 115/200. What was it? Okay, we have upload speed and there's a parameter to go into here that can set the upload port, upload speed, and we need the monitor speed. Platform IO monitor speed. Yeah, here we go. Yeah, there we go. Monitor speed at 115. Here we go. Control S. Okay, let's try that. Go back to our code here and 3. Oops, 3. That's definitely not the speed. Ah, there we go. Okay, waiting for clients. Auto connect AP. There we go. I think it was just password. Access AP IP address. Okay, starting web portal. Service star. Config portal. Oops, sorry guys. We got that much. Access point set password is valid. Okay. Okay. So this is what we have. The WiFiManager. Okay, so configure Wi-Fi. we're going to connect to, let's say that. Okay. Okay. Nope. Okay. Oh, bloody hell, you stupid thing. Okay. That didn't work. Damn it. Oh, frickin' off. I hate that when it does that. I don't even know what the damn password is in my Wi-Fi. It's too good. Oh, what was the test one? Did I not frickin' write these things down? Yeah, and then I need to figure this out. 192.168.42.5. 10. 11. No, it's not that one. I have this little Wi-Fi thing and I can't figure out what IP I put it on. Come on. Will you cut it off? The new Wi-Fi analyzer on the Android is just stupid. Where is the frickin'... I don't want the time graph. There we go. This one. Where is this? Well, 2 is definitely there. So what's going on? No, that's definitely not the site. 3, no. 4, no. 5, no. Whoops. 5, no. 6. 6 is definitely there. SSA 192.168.42.6. What the heck is this? Nope. 7? Nope. Where in the hell is it? 9, 10, 11, oops, 12, 15. Oh, crap off. Ping. No, ARP minus A. So we have a MAC address on the test network of 8738 on the last little bit. No. Ping. What's the network wide ping? Ping. I need to Ping the broadcast address. Okay, ping minus B 192.168.142.0. EBFA D-Link Knap that. It's 8. Should be 8. Why can't I not bring 8 up? Piles on 2. Yeah, that's fine. This is ridiculous. I can't do anything because I can't remember what the frick the things are. What the heck? And it is behind here. Sitting right there. Mr. D-Link, why can't I reach you now? Oh, come on, why can't I reach 8? It is the D-Link access point. Oh, come on. H. Oh, what is this? Uh, 99. No, it's not that. Off HP. Okay. Last var log bh. Do I have a log for that? No, of course not. Why would I have a log for that? Oh, come on. Get to the bottom of the log. Okay, DHP discovery from 8738. That is this, so it's saying DHP offer 145. Holy crap, what the heck is it doing all the way up there? No. Oh, come on. 8738. $221 now? Okay, let's try 221. Nope. What the heck? And we're lit. Yeah, all lights. $87.38, and then we offered a number 145. Let's try this again. 1001, 1002, 1003. We will plug it back in again. Come on. There. That doesn't make sense. Oh, come on. I can't even test this Wi-Fi out because I don't know what my freaking crap is. Ah! There we go. Ah, come on now. Now I can't remember the login on this back. Ah, there. Admin. Login. Okay. So, wireless setup. Okay. What is the frickin' passphrase? Okay. Okay. Let's wait a few seconds for that. Back to this, back to this, back to that, back to the Auto Connect AP. Configure Wi-Fi. And we will try this again. Test. And see what the debug says on here. Ah! It's up. Okay. So now we try this. And we go HTTP doink 192.168.142.107. Oh, 207. Sorry, William, you're not reading the numbers right. There we go. Okay, now, whoops, our picture would be a lot better on this camera if we did not have the little protector plate. So start stream. Ah, look. That way? No, that way? No, that way. Can we rotate this? I think we can. Face recognition. I got. Where was that? Right. Gain, BPC, WRAW, lens correction, V-flip, and possibly an H-flip. But here you go. One camera on Wi-Fi. Now I could put a battery pack, I think, on this one. Yeah, there's a way of doing it. I have a little breadboard with a battery and everything. Yeah, you could run this with battery, then it would be portable. It's actually pretty good frame rate. So we're running 320 by 240 resolution. So let's jack it up to 480 by 320. There we go. Higher, VGA. Higher yet, SVGA. Still pretty good. XGA. Now we start playing the penalty. Yeah. You can see it's stutter. So actually VGA is pretty good. What's the special effects? Negative grayscale. Okay, AW. Auto white balance gain. White balance mode. Home. That's not very good. Office. It's a little bit different. Auto. That's more correct. Don't know what the AEC DSP does. AEC auto gain control. Oh, that does with auto lighting there. See, a bit on the lighting. Okay. Lens correction. Okay. Little downside, color bar. Sensor resolution. Let's do SVGA. Doesn't change it much. But so the WiFiManager worked, and now it doesn't show up in the list anymore. Which is cool. Configured from the home. So now you can do these things. I could put this on a battery pack. I think when I unplug it, it's going to reset. I think. I'm not going to see the debug anymore because it won't be plugged to the USB port. But yeah, so okay, now I just put a battery pack on it. These two I haven't taped on the cameras yet, so this one still has its tape on it. So the funny thing is, these are identical cameras basically, but whoever manufactured this one did a better job on the USB port right here. That. And this one, I had to fix this USB port a couple of times, and I have a broken one up there that just won't connect anymore. I think one of the wires is just not making contact properly anymore, or it's blowing. So I can recover the camera stuff off there, and technically off this one here, I can actually recover this module off too. But there's something wrong in this USB. I've soldered and soldered, but it doesn't want to stay. It's something is not working right. It could be anything. It says it's transmitting whatever. I see the lights, but nothing. No one's home. Yep. And this is the one I fixed. And this is another one which yeah, this is the one of the good ones. And then of course I have these guys right here. So, oh, I did get my little oven, by the way. See? What I didn't have, by the way, you buy one of these things, buy it with the brick. Yes, because it requires a PD power supply, power delivery power supply that this tells it what it wants, which is 20 volts at 2 point something amps. So I actually had to buy a special power supply for this. Now I'm just going to kill the web page, and I am going to kill the serial over here. There we go. So we actually have everything working, except for the little trick we had to pull the branch from master over here instead of this one here. This one doesn't work. I wonder what version that branch is. Let's find out. It is 16, the latest. So why does the branch work and this doesn't work? I'm going to try compiling again, but this time without the so what I'm doing here is I'm just going to go like this, and I'm just going to build the code again and see what we blow up. And let's just raise this and we'll build again. Yeah, so see, we blow something up. Yeah, see, for some reason the one supplied from Platform IO doesn't work. And this one, what was all the yellow about? Oh, okay, I've had that before. It doesn't seem to affect the thing. But we can do a trash can on this. And then a recompile. Yeah, this is mostly just warnings. Warning, 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 warning. But it does work, so ta-da. So I'm just going to close this code window up. Close the world. No. Do I have a workspace in here? Yeah, I do. So file. Oh, file, close folder. Okay. So this works, and now when on this particular board, make sure you put your finger and everything on the USB port and pull straight out. Otherwise, as I said, you might break them. So those are those, and I had a little bin open with ESP32 cams right here. I'll just put these back in here for the moment. Now, I haven't tried this out yet in the last little bit for the day. What did I do with that? Uh-oh. Oh, here it is. So this is, technically, it's a specialized power supply for a Dell laptop. Actually, I'm going to save this little box. Like so. Okay, and I think we will take this plastic off, like so. We don't need it. And then there's a peel to be had on the back side. There we go, one peel. And then we have our power cord. It's actually not a bad power cord. And what we need from over here, just take off the Raspberry Pi power. Put this in here, and we put this in here. Like so. Now, oh, cute. I get a little light on the end. Whee! Okay. So the idea behind this, I think I have enough power for this, is to plug this in. So we'll click the little buttons in the back. Yeah, it's getting warm. Gotta be careful here. So the temperature on these things, the temperature on these things is actually relative to the solder paste. So I did get, do I have it here easily available? No, I don't. I have to go find it. I'm pretty sure I put it away. But you can definitely feel the heat on this thing. So, little thing. So it's working correctly now. Now, of course, don't put this thing back on when it's blistering hot. You just melt it to it. That wouldn't be a good idea. So now the idea is, do I have my projects bin up here? Yes, projects. So the idea in here is this board, these parts like this. So I would not this through hole stuff, but all the surface mount stuff that's in here. This board has a bunch of it, like all these chips that go on here. That's actually in here. So it's red, so it's ready to go, I think. And these are going to go on here like so. So I had to put the solder paste onto these pads. You put this on here, and then you put this on here, and you wait, and voila, it goes like that. So that'll be my first. So I have all the parts, I think, for these guys, these three boards, like so. These are the RGB Raspberry Pi RGB LED matrix 3-port boards. So that's what all this is for. And then somewhere up here, I don't know exactly where I put it. Button cell, USB dongles. Did I put it in here? Oh, by the way, see these things? I tried one out in my soldering thing. Look how thin it is, right? Put water on it, boing! It just expands like you wouldn't believe. So in here, do I have it? Yes. So here is the solder paste, right? Supposed to stick this in and blah blah blah, and you have different tips for dispensing it, right? This is liquid rosin. So yeah, it's definitely warm. Okay, so I'm going to just unplug it, and I'll let it cool down here. I'll just put it over here, get it out of the way. But this is working. So what I probably need to do with this plug is feed it behind the shelves and stuff. I will have to think of something up. And I can actually start doing that. I can also, no, this doesn't require that board. But I think I have another thing somewhere that requires surface mount melting. The RG, I definitely know that one does. And then my little Wi-Fi access point here can go behind the thing again. Doesn't need to be visible. And the camera thing and all that. So I don't need that. That can go in there. Yeah, I have another one. I don't know what I did with it. There was another one I wanted to do some surface mount stuff on, but I'll have to find it. But that should be it for today's rambling about in random directions. So we know we have to get a DB9. That's missing. I think I can find a scrap cable at work. So I have to find a female DB9 so that I can build that serial cable for ATDT or something like that. And I know I have to get the battery thing set up again for the ESP cam again. But this ought to be cool. I want to try it out at work. So take the cam to work and plug it in and have it do all its stuff. That should be neat. So I will let you go. You can have fun for the rest of the day. Class dismissed.